to welcome everyone to tonight's Citizens Climate University. It's a weekly webinar program of Citizens Climate Lobbies that provides CCL supporters like you and I with access to in-depth training and topics pertaining to climate change and effective climate advocacy. I'm your host, Brett Cease, and tonight's topic is on global carbon prices to achieve 2 degrees Celsius, looking at both the En-ROADS model and the Energy Innovation Act. Now, to get us there, we have 3 wonderful learning goals and 2 esteemed presenters. We're going to have a chance after tonight to have a threefold objective. First, we're going to explore the credible literature on the carbon prices needed were they to be adopted globally to achieve the 2 degrees Celsius target. Second, we're going to compare the UN's high-level commission report on carbon pricing's pathway to 2 degrees Celsius to the En-ROADS model's path to that same target and see where those 2 paths are consistent. And then lastly, we're going to have a chance to discuss the evidence that that baseline carbon price in the Energy Innovation Act is a sufficient first step to achieving that 2-degree goal. To get us there, we're going to have 2 wonderful presenters. First up, we'll have the wonderful Jerry Hinkle, CCL's Economic Research Coordinator and a board member or the Board of Directors member for CCL. Jerry's been giving public presentations on climate change since 2001 and has been with CCL since 2011. He started what's now known as CCL's Presenters and Schedulers Action Team and the Economics and Science Policy Board Network Action Teams. And with Jerry is the wonderful Andrew Jones. Drew is co-founder and co-director of Climate Interactive, an expert on international climate and energy issues. He's a system dynamics modeler, keynote speaker, and designer of simulation-based learning environments for many years, trained in environmental engineering and system dynamics. He is a former Rocky Mountain Institute employee, and in the 2000s was with Dana Meadows at the Sustainability Institute. He is now teaching system dynamics at MIT Sloan and at Keenan Flagler Business School, University of North Carolina, Chapel Hill as well. At this point, we will defer to Jerry first to walk us through our agenda, but we are so glad all of you are on the line tonight. But the floor is yours, Jerry, and thank you all. You're in for a real treat.
Brett, thank you so much, and thanks everybody for joining us tonight. It should be a really informative session. Here's our agenda. The first thing we want to do is look at the high-level commission report and their path to achieving the 2C target, constraining the global temperature increase to 2C. Then we'll look at En-ROADS and how they can achieve the 2C target. And then we want to answer an important question. Are the baseline carbon prices in the Energy Innovation Act, are they sufficient? Are they sufficient applied domestically to attain the types of science-based targets we have said are our goal? And if those same prices were to be adopted globally, would we be able to meet the science-based goals as well? The UN took very seriously the question of global carbon prices and what it would take to achieve the 2C target. So they put together this really important high-level commission chaired by some of the top names in the field. Joseph Stiglitz from Columbia is a Nobel Prize winner. Sir Nicholas Stern, I imagine you've heard of. He was the former chief economist of the World Bank, and he authored the Stern Review. And if you look at the list here, it's our own Adele Morris was on the commission as well. And to answer the question of what global carbon prices would be required to meet this 2C target, they really unturned every stone, I want to say. They really did an intensive, broad survey of the literature. Let's go next to the conclusions that they drew. So their bottom line conclusions were that global carbon prices by the year 2020 of $60 to $100 a ton, rising gradually from there to $75 to $130 a ton, would get you on the path to 2C. I want to note here, if you look at the report, you won't see these numbers. The reason is I wanted to, the report was in 2005 dollars, and I wanted to give it to you in current dollars. So I inflation adjusted these figures. You kick them up by a third. for inflation between 2005 and 2020. Now, this is just the start. What about prices after 2030? The commission made a clear point. There's significant uncertainty how much emission reductions are going to be generated from these prices. We don't know after 2030 yet. Let's see how far, let's see what difference these prices make and then reevaluate at 2030. And I also want to make one other point. But they did say, look, we'll take the models that we use to derive these estimates and we'll show you what they said about necessary prices in 2050 to give you an indication of the longer term view. I'll show you those prices. I'll show you their graphic in a minute. Before I do, I want to make one other point. If this commission were to write this report again today, would it be the same or would these prices have to change? I want to assert to you that they would have to be higher. Obviously, they would inflation adjust them themselves. They'd give you these prices in 2020 dollars. But in addition, where are we at globally with respect to these prices? We're behind. We have some global carbon prices in 2020, but we are not at a global carbon price of $60 to $110. We would have to raise these prices in order to meet the 2C target. Because we're a bit behind, we have to catch up. So go ahead and scroll forward. So what did they say about 2050 prices, meet 2C? And again, these are just an indication. They didn't hang their hat on these, if you will. But here we go. We got three scenarios here, but I'm going to focus on the middle one, SSP2. And the reason is, the first scenario, they don't know what the world's going to look like out 80 years. So the first scenario is, what if GDP and energy use and emissions were less than expected going forward over the next 80 years for a variety of reasons? Well, you'd need lower carbon prices to meet the 2C target, right? SSP5 at the bottom, the opposite. What if we had much stronger growth, much stronger emissions than expected? Well, you'd need stronger carbon prices to meet 2C. We're not going to focus there. We're going to look at SSP2. This is the expected scenario. And what you see is you've got 5 models there. And there's a cluster around the price, the 2005 price of $200 a ton, needed by the year 2050 to meet this target. Okay, so in today's prices, that would be around $265 a ton. So I want to make the point here that how does the Energy Innovation Act baseline scenario look with respect to the UN report if those prices were adopted globally? Because you guys are working real hard out there, our volunteers, and you want to know, are we on the right track? Is this going to get us there? And there's been at least some questions. So the information that the high-level commission has provided would indicate, yeah, we're pretty much on the right track. And by that, prices of, 80 to 130, whatever it was, EICDA prices by 2030 would be 105, sort of right in the middle there. By the year 2050, baseline Energy Innovation Act prices would be a little over $300 a ton. So it looks like, and these prices, 265 is low, but it looks like we're in the ballpark. It looks like if our prices were adopted globally, that we'd have a real good shot at meeting these targets that are so important to us, like 2C. Here's the question. We saw this information and we were telling this to our volunteers, and we wanted to see the degree to which it gelled with the key message coming out of En-ROADS, because we're clear that is a beautiful model. That is a fabulous interface. Our volunteers love it. They're going out, they're giving presentations to their communities. And all of a sudden, miracle of miracles, people are finding climate policy fun. So as far as I'm concerned, Drew gets the next Nobel Prize. This is a remarkable feat, and we are indebted to him, and we are incredibly grateful for his partnership. But we wanted to say, okay, look at the high level commission's kind of saying carbon prices alone, as long as they're sufficient. En-ROADS is saying, you know, carbon prices need a little help. Is there a bridge between these two messages? Drew and his team, and then myself, Rick Knight, and Paul Bernstein, just a fabulous volunteer, dug in. We really put Drew and his team through the ringer on this one, but we came to a pretty solid conclusion. Yes, you can bridge the two messages. And the bottom line is the UN had a different question to answer. The question they were answering is, if you just relied on carbon prices, what would it take? Okay, so they applied carbon prices very comprehensively. They applied it not just to energy emissions from CO2, but greenhouse gas emissions, non-CO2 greenhouse gas emissions, okay? Methane, NOx, F gases. Also applied it to very important sources of greenhouse gas emissions globally, forestry and agriculture. So forestry, think of not degradation, but deforestation, the burning of these forests. It's a huge source of emissions. So they're saying, we're gonna take this carbon price and we're gonna find a way to compensate people to maintain those forests, those carbon sinks, if you will. And they went even a step beyond this, which is vital for their exercise. As many of you know, you can't readily meet these science-based targets simply through emission reductions alone. There's just not enough emission reduction. You're not going to wring all of these emissions out of the economy. So at some point, within a few decades, you're relying upon carbon removal technologies, okay, to meet these net zero type targets that are necessary. Well, the UN is assuming here in their modeling, not the UN, excuse me, but the models that went into their analysis, assumed, look, if we can pay someone, or if we can charge someone $100 a ton to emit greenhouse gases, then we'll flip that on its head. We can pay someone $100 a ton to remove those greenhouse gases from the atmosphere. So En-ROADS is answering a different question. And what they apply their carbon prices only to CO2 from energy. And that's fine. Now, as you well know from being users of the model, there's a lot of other ways you can reduce emissions in En-ROADS. And you can do carbon removal. What motivates those? What drives those? Is it a carbon price? They simply don't answer that question. And that's completely fair. That's not the purpose of the En-ROADS model. It is simply to show you how you can get there. So again, we thank Drew for all the hard work that he and his team did to help us feel good about the messages coming both from the High Level Commission and from En-ROADS. So I'm gonna hand it over to Drew at this point.
Thank you, Jerry. That was just so clear and right on, and just appreciate the excellence of just laying out where we stand with thinking about that important analysis from the integrated assessment models about what it takes to get well below 2 degrees and bridging the work with En-ROADS. Particularly, I'm thrilled because we're just so thankful to Citizen Climate Lobby and all you guys for delivering on the mission that we have. We build these tools, as you've seen, and we want people to go out there and make a big difference on it. And in making a big difference, what a powerful way to get EICDA passed. And I'll just speak personally, my great dream of this next year would be somehow to see this bill passed and then spread around the world. So I'm so happy to be here and excited to show you some of our analysis using En-ROADS, and along the way, maybe give you some tips about how you can use it to engage others. I think you probably see the interface right now, and really, we're going to focus a little different from how I've framed this to you in the past. It's really a systems perspective. We want to come up with the actions, simulate the EICDA, but also think about what are the system-wide impacts that you can start understanding how to address climate, but also the other things that we care about right now, we're concerned about. Justice and equity and other forms of health. We call it multi-solving. And the model helps us do that. How it's going to do it, of course, some of you, maybe you haven't seen it, but The basic idea, of course, is that you can hit a button and then see what the impact would be in this simulator. Now, it's important when you see this scenario of, first of all, just the baseline scenario. You can see in the top left, I'm going to undo that run. You can see we just kind of made a business as usual future. Where did we come up with that? It's from 2000 to 2100. That brown area is coal, all the coal that would be burned under that business as usual future. On top of it is the oil. On top of that is natural gas in blue, renewables, bioenergy, and nuclear. So first, where did we come up with that? And then when we look at one of the many outputs, CO2 emissions, for example, and we increase the carbon price, we see, well, what did we increase it to? We can look and see, well, there was a price there of $185 a ton. Carbon dioxide emissions went down following the blue line. It departed from the black line. Why do you have confidence in that? Why do you think it goes down that much and not less and not more? Well, this really relies on the testing that we've been doing. And what we did is we tested our model against the very models that Jerry told you about. Over on the right, you can see that. PBL has the image model, YASA in Austria, the message model. PNNL has GCAM, PIC in Germany. There's an Asian model. These are all of the models. And the red lines are their business as usual future from 2000 to 2100, their baseline. And then various lower levels of warming for the variable of greenhouse gas net emissions. So the test was take the carbon prices that they tested in those models, stick it into En-ROADS and see, cross your fingers, are the results similar? That would build our confidence. It doesn't verify the model, but it would build our confidence that we're on the right track, that our model is good enough for this kind of use. So I'm going to run it a couple times and you'll see the red line goes kind of in the envelope of the other models, and the orange line and the yellow line. This builds our confidence that, like, okay, the results that we're getting are consistent, as it says in the headline, with the integrated assessment models that are behind the UN report that we just heard Jerry talking about. So if we believe that when we put a carbon price in, we get a similar result, particularly for carbon dioxide emissions, because, as Jerry said, En-ROADS tests the carbon price on energy. That's what we modeled. Unlike those integrated assessment models that kind of, in a modeling exercise, imagine a much broader scope. We try to say, well, what does a real carbon price look like in the world? In the world, it looks like the EICDA, which covers energy and also F-gases. So here's where we are with the business as usual future. The first thing that you want to explore, just to show you how great a carbon price can look in a model like this, is try some of these other things that people are talking about. And I love asking people, you know, what are the things that people talk about? Oh, we should electrify transportation. And I'm going to change that right here. I'm going to hit the button. Now watch the big impact. Wait, oh wait, that's energy efficiency. Excuse me. That was pretty big. Electrification, let's try this again. Wait, 4.1 went down to 4.0. We didn't decarbonize. In this case, it doesn't help that much. It doesn't help if you just electrify. That's one of the things I hear talked about a lot. It doesn't really help so much. What about growing a whole lot of trees? Now, mind you, we should grow a lot of trees. Trees are good. And yet, as a climate solution, let's go look over here and see carbon removals. Well, there it is taking us, wait, I'm gonna undo, excuse me, let me just undo those. We're just gonna do growing trees. 4.1, again, goes to 4.0. We get about, what, 6 gigatons a year, but so late in the century. In the same way, just focusing, say, on a new technology, like we could focus on some new research and development into thorium fission. Maybe that's gonna save us. Andrew Yang suggested that. Let's test it. See the orange wedge growing up top there? 3.9. If we got a lot more, 3.8. The point is, there are many things that some of them we may need to do, but wait till you see what your proposal that you're fighting so hard for gets you. I think you know where we're headed here. So I'm going to go under carbon price. And as we know, under the EICDA, it starts at $15 a ton. And I'm going to start just with that and watch over on the right. It just jumped up to $15 a ton. You can barely see it on that graph in the bottom right. And it's not phased in over 10 years. We're going to imagine it phased in over just 1 year. So it jumps up pretty quickly. But then let's imagine a long-term growth like Jerry was just talking about. I'm going to do this in a funny order. I think we want to start it in 2021, right? It's going to start after that first 15. And here we did the math to say, if it went up $15 a year, it would get up to the maximum we can show and approximate the EICDA in 58 years. So that number is going to be 58. And by the way, the numbers I'm putting in, Janet just today wrote a FAQ on the En-ROADS website. So maybe you could send that around, Janet, that'll show you how to simulate this. So I'm going to put in where it would get after 58 years-ish at $15 a ton is $8.50. So here comes $8.50, and watch the impact. But actually, I said watch, but don't use it like a crystal ball. Don't just hit go and then see what it would do. Ask yourself, ask the member of Congress, what do you think it would do? This is the systems thinking part. What would happen to coal, oil, and gas, renewables? What would happen to these wedges? Look at the brown wedge of coal. What's going to get more affected? The brown wedge of coal, oil, and red, blue, and gas. We know they're going to shrink, right? What's going to shrink the most? What's going to happen to that green wedge of renewables? I'm going to hit tab, so think, and here we go, and then we get to see. Boom! And I'm going to hit the replay button here, and we see the huge impact. Coal in brown takes the biggest hit, almost to zero. Why? Because look, that carbon price is going all the way up, and coal, of course, is the most carbon dense of the supplies, the most on the economic brink. And mind you, this is a global model. Don't think of the US here, where it's already kind of heading out. Think of India, China, South Africa, Brazil, Philippines, Indonesia, South Africa, all over the world, hitting coal the hardest. The red area of oil hit some, not quite as much. Gas goes down, and then watch that growth in renewable energy and some nuclear. Okay, but then I want to ask you, just think, we called it multi-solving. We're so concerned right now about justice and equity and environmental justice. So many of those coal-fired power plants are sited next to the marginalized communities that are so prone to the impacts in asthma and lost school days. How can we explore other impacts, such as helping, that is multi-solving, for other things like environmental justice? So you can look under here and say, well, what's happening to coal? Let's look at over here, coal prime, and think about what's happening to coal, and therefore to emissions of PM 2.5, of air quality. What would be so beautiful about a world that didn't have coal around the world growing with the black line, but instead falling like the blue line? We're looking across the system for other impacts. Some other impacts that are interesting to look at. What about sparking innovation and energy efficiency? If we had this carbon price, there would be so much more of an incentive to invest in energy efficiency. So I'm going to go over here and we're going to look at the energy intensity of the GDP. How much energy does it take to deliver $1 of value? The black line shows that it's falling already. That black line means energy efficiency is going up. It takes fewer exajoules per $1 trillion. That number is going down. It's already going down some, but with the blue line shows the effect of the carbon price. More and more energy efficiency around the world. What about electrification? What would that drive regarding the spreading of electrification in transport? So I'm going to look over here under energy demand types and totals. I'm going to look at energy demand types. I know I've got consumption types, excuse me. Electric share and transport. The black line shows the business as usual for electrification of transport. Look at the blue line. It's driving innovation around the world, more system-wide impacts. Also, we talked about the fact that it's just affecting carbon dioxide. But wait, what about methane? A huge source of methane is the whole oil and gas industry. The oil and gas industry, I just showed you, look at the, right here, the oil is red, goes down, gas goes down. Well, what happens to methane emissions? Another pollutant. Well, let's look over here and we can see greenhouse gas emissions. Let's look at methane. Methane without anything in agriculture, in landfills and all those other areas, it's already following the blue line. The secondary system-wide impact of helping with another gas indirectly with this high and rising carbon price. Also, there's a big important word in EICDA, that is the dividend. What about all that money? And look down here to financials and you can explore revenue and cost. Here are the revenues. The green line shows you $1 trillion per year. In, what is that, 2030, 5 trillion. Revenue, dividends to people, 8.7 by 2040, rising all the way up here, 11.8 by 2060. The point here is to look across the system to find these co-benefits and multi-solve. Also, we should be sober and look at the co-costs. And one of the more challenging things, of course, that we've haven't modeled precisely would be, we've got to make sure that energy prices, say for marginalized communities, for people, price for people to get around, to get to their jobs, pay the electric bill. This is a very gross measure of cost of energy. You can explore the fact that energy would go up. Of course, that cost of energy would go up. So that needs to be explored about the just transition to make sure people are okay as we really change the way that we pay for energy and the carbon price and the way the dividend could help with that. So first I want to just get you all the system-wide benefits of this. But then it brings up another question. Wait, we didn't get all the way down to 2 degrees. This says 2.6. And again, this really is what those models, the integrated assessment models, say. Now, there is another benefit from the EICDA, and that is in F gases. We can't really do it exactly. We don't break out the F gases as a lever, but we can go look at them and see, why do we still have warming and how much would reducing F gases help? I'm going to go back and show you this important graph to show you why we still have warming. This is a stack graph of all the pollutants. See the green area? It's from 2000 to 2100. The green area is land use change in forestry. That's deforestation emissions in green. Pretty small relative to that big area of energy emissions that this carbon price is addressing. That gold band is F gases, SF6, HFCs, methane in blue, and then nitrous oxide on top. So with the carbon price, what's fantastic is the huge cut it takes out of energy CO2 emissions. And we tried to approximate it. We think that maybe one way to approximate the F gas part of EICDA is to go down here, industry and energy emissions of methane, NTO, and F gases. And if we reduce that about 10%, then it actually is going to reduce a little bit more, but it's pretty small. That yellow area just shrunk a bit. We would need to do more. So you can see, why do we only get to 2.6? Well, we still have a lot of emissions. What is the largest source of emissions in the latter half of the century? Methane. So a carbon price that covers energy and F gases would need to, as Jerry was talking about, expand to cover also methane and other gases in landfills, in agriculture, that's rice and cattle, and waste. We already did some things in oil and gas leakage. So let's see what happens and supplement what we had with some other things that we can do. So here's methane. You'll see that 2.6, we've already reduced it because we've already put the hurt on oil and gas. What if we reduced ag and waste emissions 40% of what is considered the maximum that those integrated assessment models could consider? So here we go, 40%. Watch the red. Gosh, I'm so worked up. You got me fired up. Watch the blue band in the top right. Watch the blue band in the top right. So see it shrink? You saw that. When we cut that, 2.6 goes down to 2.3. Methane is a big deal. N2O, agricultural emissions. Let's go figure this out, people. How can we get a methane price? How can we get a nitrous oxide price? How can we expand a carbon price to include agriculture? Also, energy and CO2 and industry emissions here, -40 would get us some more, 2.2 degrees. We also know deforestation emissions, and this is what was done by those integrated assessment models. They consider a significant cut in deforestation emissions. The business as usual is to the right, where it's staying flat. But what if we had a 5% per year drop to basically eliminate those emissions? So look at the green area, the green band. It used to be above the zero line. If we have it reduced, then it goes below zero. So we actually are pulling carbon out of the atmosphere, 2.1. And then, as Jerry said, what the integrated assessment modelers imagined was breakthroughs in some combination of carbon dioxide removal. So far, we've looked at cutting the emissions into the atmosphere. Now we're talking about pulling more out. One thing I love about a carbon price is that it's so critical to focus on reducing the emissions before they get into the atmosphere, not trying to pull them out later. If your bathtub is filling up with water because there's a leak, first you focus on stopping the leak. You don't go for mops and buckets. Cut off the source. That's what a carbon price does. But we're learning that it may be necessary to go further. So what we imagined here was carbon dioxide removal. And when you do this with your constituents and your members of Congress, take the time to look at which of these 5 you think are reasonable, learn about them: bioenergy, carbon capture and storage, direct air capture with carbon capture and storage, enhanced mineralization, ag soil carbon, biochar. A really simple way, because we don't have that much time, I'm just going to say, well, what if we had 60% of the potential that's out there? What if we had 60% of that potential? So what I'm going to do is move this up to 60 and look at the removals over in the top left. As I change this up to 60, here it comes, and boom, that's over 10 gigatons a year, a combination of those 5 different types. They also said, let's grow a lot of trees. I'm going to put this at 50%. And what if we have growing more trees and watch the afforestation grow? And there we are, if we put together that suite of actions and get to the level actually that the integrated assessment models got to when they tested for the HCL report, which was 1.8 degrees, well below 2 degrees. So I'm just going to pause for a second and see the journey that we just went on. What we just looked at was carbon price kind of approximating the EICDA, starting immediately, rising steadily, that covers energy emissions. And then we explored what could supplement it in 3 areas: land use change in forestry, other emissions of methane, N2O, F-gases in agriculture and in other sectors, and then carbon dioxide removal. And note, a lot of carbon dioxide removal, to the point where we would be dedicating 2 Indias of land. So they have a big assumption about how much land could be dedicated just to carbon dioxide removal. But putting together all of those actions, we would see greenhouse gas net emissions falling. We'd have net removals. People talked about getting to net zero. Of course, you could explore that. We'd have net zero CO2 here in this scenario, 2070, and we would get to well below 2 degrees. How to do it? There's no silver bullet, of course, but the most silver-ish bullet in this whole scenario was that carbon price that was so powerful in growing and rising and keeping so much coal, oil, and gas safely in the ground, such that we saw this radical transition of the energy system away from fossil fuels to renewable energy, bringing abundant co-benefits in air quality, environmental justice, and other impacts around the world. And I really believe you guys are so key to making it happen. So there's my summary. I really hope you all can deliver on it, because I want to see it so badly.
So fabulous, Drew. Thank you so much. I want to switch gears a little bit on you, because we have a final important point to make. You're out giving presentations, and it's really about the levers that will reduce emissions globally. En-ROADS is a global model of these climate policy levers. One of the things we're really interested in at CCL is working with the US Congress about US policy, and we're interested in domestic models. How do you reduce emissions domestically? And we've got a couple of good models to show. The first one is here. Maybe you've seen this picture. The House Select Committee on the Climate Crisis just issued their action plan a couple, 3 weeks ago, okay? And their target was 0 net emissions in the US by 2050. They talked about a carbon price, but they demonstrated this model from energy innovation, okay? And what they demonstrated here is how emissions would decline relative to 2010 levels by the year 2050 with a series of regulations. Okay, and so you can read some of them here. Some of them make more difference than others. A clean energy standard is huge. A fuel efficiency standard, the ZEV sales standards, the zero emission vehicles, etc. So I'm just showing this to you to show this is a US model. Be careful when you're using En-ROADS and trying to translate that to US emission reductions, because the translation is not perfect. Okay, some of the levers are going to be really similar, some of them are going to be quite different. One of the models that Drew just showed you from the high-level commission study was GCAM or GCAM. Okay, that GCAM model was a global model. There's also a US model. That is being used by a set of researchers. This is a forthcoming publication in a top journal. I can't say anything more about it than that, but you'd recognize some of the names of the authors. And what they were pursuing is what US carbon price would be required to achieve zero net CO2 emissions by 2050. Okay, and here's what they found. CO2 prices in the year 2025 of $34 to $64 per metric ton, rising to $77 to $124 a ton by 2030. We'll achieve net zero CO2 emissions. Okay, I probably don't need to tell you this, but I'll underline it anyway. Those prices are exactly consistent with the baseline scenario of the Energy Innovation Act. So what's the point? Up to this point, we've been talking about global carbon and what it would take to hit 2C. Okay, the first step for the US is strong legislation that gets us to near zero emissions in the year 2050. That's a very commonly bandied about target. Our looks from this analysis, from a very reputable model, it looks like our path, our carbon price path will get you there. Why do I tell you this? I just want you to know, I mean, there was a question bandied about for a while, is our bill enough? Sure looks like it is. Sure looks like it is. So I want you to have that confidence when you go into your lobbying meetings, that what you're proposing, what you're advocating for is the critical first step for the US to take to get the globe on a path to 2C emissions. And that is it for me.
So let's give a huge round of applause for both of them on the line. I would love for you to highlight where to go to find out how to get trained. That's exactly the one.
Well, there it is. Janet, maybe you could send this link. But actually, someone on the call said, I missed which name it was, but that they just completed the 8-part training course. So there's 8 webinars that teach you how to run this workshop that I just led for you, an interactive conversation about how to get to well below 2 degrees and the power of a carbon price to do so. So what you do is you go here and you sign up and take the course and join us in using this as part of your volunteer work with Citizen Climate Lobby.
You're always welcome to post questions on our forums. They're a really ambitious place. They get a lot of activity every day. Drew and Jerry, you're getting so much love here. Everyone is saying great job. It's so generous of your time, and you're the best. Outstanding, standing ovation, powerful teaching tool.
Aww.
Thank you. I'm going to unmute all lines, and we are just so grateful for all of you being on the line tonight. And again, thank you, Jerry and Drew.
Thank you.
Have a wonderful night, everyone.
Thank you. Good night.
Thank you. Thank you.
Great job.
Thank you for listening to this episode of Citizens Climate Lobby's training program. You can tune into more episodes anywhere podcasts are available. Inspired by what you heard today? Join Citizens Climate Lobby to advocate for bipartisan climate solutions. Go to community.citizensclimate.org to find more trainings, resources, your local chapter, national action teams, discussion forums, and more. Be sure to like our Facebook page and follow us on Twitter and Instagram @CitizensClimate. We also invite all of our listeners to subscribe to our YouTube channel for more inspiration. And together, we are creating the political will for a livable world.